So in this lesson, I'm just going to give a kind of a quick overview of what we did for problem 3.2 in samples and populations. And this was a good problem to look at how random sampling can be used to kind of solve a real world problem. In this case, we have a set of 12 chocolate chip cookies here, and the owners of this custom cookie counter were guaranteeing that you would get 5 chocolate chips in every cookie. And in order to do that, they would take a batch that would make 12 cookies and put just 60 chocolate chips in. And the assumption being that when they scoop the cookies out, that the 60 chocolate chips would randomly be equally spaced with 5 in every cookie, which of course I think most of us could reason out that that doesn't work out that way, that some will have 3 and some will have more than 5, like 6, and so they just don't equally spread themselves out. So you would definitely have to use more than just 60 chocolate chip in the batch in order to make sure that they would all at least have 5 for that guarantee to be true. So what we did in this activity as a class is that we actually simulated the 12 chocolate chip cookies. So what I have here is an example of a way to try to figure that out. So if you had 12 cookies and you were just to randomly generate numbers using a graphing calculator, this is what I actually did in this case. Was I used the math PRB random integer. This is a random integer generator that a calculator will use, and I did the numbers 1 through 12, 1 comma 12, and then this now will randomly pick out of there. So if the number 1 came up, that means that the cookie number 1 got a chocolate chip. And I just kept doing that, and then 2 came up, and that one would get 1. And it's not going to keep going in order. There's 6 came up, and that's random. So the marks that you see on my page are from when I did this, and they back to 2. And the idea was that I kept going. I kept doing this over and over again until all of the cookies, all 12 cookies, had at least 5 chocolate chips. In fact, the cookie number 1 and cookie number 11 each only ended up with 5. But some ended up with lots more than 5 because randomly they would sort of go everywhere in this case. And so it took me, in this case, 144 chocolate chips before I had all the cookies with at least 5 in it. And what we wanted to find out as a group was how many chocolate chips would we have to put in a batch to pretty much ensure that every cookie would have at least 5 if we're going to make that kind of guarantee. So we did this activity as a class, and on the next page I have the data from my entire class and for this particular group of students, and you can see that there's a whole variety of numbers, 121, 130. So these were all the different students who each did this, how many it took for them to get 5 in every chocolate chip cookie, which is kind of the idea in this activity, is to see, what does it take? And you see numbers vary, but the nice thing is when we got done, we have a nice range. Our minimum was 81 and our maximum was 165, and we have these quartile numbers. We do a 5-number summary. And we looked actually at the interquartile range to see if there were any outliers, any numbers that were just really beyond what we would expect, and we didn't really. And then we actually calculated the mean. In this case, was 117.8, which is very close to the median. So if we took these numbers and put them in order from least to greatest and found the middle number, it would be about the same as if we added them all up and divided by how many there were. And so that gave us some good information, and we made a box and whisker plot out of this data. This is our 5-number summary, our minimum, lower quartile, median, upper quartile, and maximum. And then also a histogram. We just took the data, and it looks like right in here is where the middle is. We had 117 was our median and mean, and so 117, kind of the middle of our data. Middle numbers, maybe a little closer down to this end. And so what we did was we decided to use a number somewhere in the middle for the number of chocolate chips that it would take to pretty much ensure that every cookie had at least 5 in it. So again, we went and we chose a target number of chocolate chips, in this case 120, which was a little more than our 117 that we had as a mean. And then each person once again did the experiment or the activity over again. So I, once again, with my 12 cookies, I continued to do this, and I used a maximum of 120 chocolate chips because that was now our target number. And so we were able to do that, and I used 120 chocolate chips, and every one of my cookies all had at least 5 chocolate chips in it. And so I went again around to each person in the class and asked them, yes or no, did you have at least 5 chocolate chips in your every cookie? And so we had 1, 2, 3, 4, 5, 6, 7, 8 out of 28. So 20 out of 28 trials that, so if I think about that, 20 out of 28 of the trials of the people that did this, 1, 2, 3, 4, 5, 6, 7, 8. And this is really where we were trying to get to, 20 out of 28 trials that had at least. Now, and we went back to these people, each person in this 20, these 8 out of the 28, of their sets of cookies, each one of them only had 1 cookie that did not have at least 5. So really what that meant is that we had 8 cookies out of all of the cookies, 28 times 12. And so we actually thought of this as 8 out of 336 that did not have a chocolate chip cookie that had at least 5. And so the converse of that, if we took the difference, then we had 228 out of 328 out of 336 cookies that had at least 5 chocolate chips in it. So we wanted to find the percent. 328 divided by 336. And so really we had 97.6, or we'll say 98%. 98% of the cookies had at least 5 chocolate chips in them, using 120 as our target number. So using 120 chocolate chips, 98% of the cookies were able to successfully have at least 5 chocolate chips in them. Now that's double the original number. And so one of the challenges is, well, is it reasonable to put that many chocolate chips into a dozen cookies? Because you have some of these cookies that are going to get 15, and some that are going to have 6. And so by using a random system, 120 is probably a lot. And realistically, in a real life situation, they probably would be a little bit more evenly spread because we would mix them in. And so we would try to overcome the whole issue of random by mixing. So this isn't a perfect scenario situation, but it does give us an idea that yes, we can at least try to ensure that almost all the cookies have at least 5 in every one by increasing the number to something around the mean or median number of chocolate chips that it took to get 5 in every cookie. So kind of the final task in this is to make a recommendation. How many chocolate chips would you put in a batch to have at least 5 in each cookie? And again, our mean and a median number would be fairly reasonable. That's what we chose, right around 120. And so I could say 120, and the justification for that is that it's the 120 is close to the mean and the median. Those measures of center that we have been learning about, the measures of center are numbers that are average. On average, it should take 120 chocolate chips, or right around that, to ensure that all the cookies. Now, it's hard to be sure that we could ever get all of them, but only a 2% error, only 2% of the cookies that don't have 5 chocolate chips in them, we could probably live with that. In fact, one of our advertising slogans might be, because we know that 2% of the time it's not going to happen. So, we could say if you don't get at least 5 chocolate chips, then you get a free cookie. So that's one way we could sort of advertise around that and know that we would probably about 2% of the time have to give out a free cookie, which is not probably a real high number of situations. Only 2% of our cookies using 120. Now maybe we would go with fewer chocolate chips and have a higher rate of failure or a less rate of success, depending on how you're going to think about it. And all of that goes into, if you're running a business or trying to decide what makes sense. That's why we kind of this idea that we can use these numbers to make decisions about what the predicted amount of failure or outcomes will be based on probability, not just simply based on sort of what we think or feel. So there's where mathematics can be useful. And that's what we did in problem 3.2. So that might help you if that's a problem you're working on at home or weren't here for, or even were here in class and want to kind of remember what it was we were doing with all these numbers.